In the previous mathematics classes, we were talking about first PUC syllabus. Today also, I'm going to discuss one of your first PUC chapter. It is complex numbers. It's again a useful chapter for your CET examination. Before I start with problems on this, let us first recall the definition of complex number and the properties of complex numbers, and then we will go to the problems on this. Suppose if you have two real numbers x and y, or any two real numbers, and I, it is root of minus 1, which is imaginary number. Then if you take any number of the form x plus iy, so you form another number combining the reals with imaginaries. Such kind of number is going to be a complex number, and it is denoted by z. So z is equal to x plus iy. This is a complex number where this x and y are going to be the real numbers. Now here this x is called as a real part of complex number z. Real part of z. If you want to denote that in the simplest form, so I can write it as REFZ. And this y, which is the coefficient of I, that is called as imaginary part. So we call it as imaginary part of complex number z. Imaginary part of z. It is denoted by Im of z and the Prithvi. These are the notations what you already studied in your regular theory classes. Suppose if you make the real part of complex number as 0, so z is purely imaginary, right? So it is purely imaginary. ಇದನ್ನ ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಬೇಕು ನೀವು. So z becomes purely imaginary if real part of z is 0, and z is purely real, so it becomes purely real if imaginary part of complex number z is 0. Purely real ಅಂದ್ರೆ imaginary part ಅನ್ನ 0 ಗೆ equate ಮಾಡಬೇಕು, and if they say purely imaginary, real part of z ಅನ್ನ 0 ಗೆ equate ಮಾಡಬೇಕು. Now suppose if z is equal to x plus iy, then modulus of complex number z is given by root of x square plus y square, root of real part square plus imaginary part square. Generally ಅದನ್ನ r ಅಂತ ಬರೀತೀವಿ. So then theta, this is called as amplitude of the complex number z. ಅದು ಹೇಗೆ ಚೂಸ್ ಮಾಡೋದು ಆಮೇಲೆ ಹೇಳ್ತೀನಿ ಮುಂದಿನ ಇದರಲ್ಲಿ. So it is given by the formula tan inverse of mod y by x. If you find out the amplitude and the modulus, then if you write z is equal to r into cos theta plus I sin theta, this is called as polar form of complex number z. And that cos theta plus I sin theta in the brief form, you can write it as cis theta. So cis theta ಅಂತಂದ್ರೆ this is nothing but cos theta plus I sin theta. So ಹಾಗೆ polar form of complex number r into cos theta plus I sin theta, you can write in the simplest form r into cis theta ಅಂತ ಬರೀಬಹುದು. ಹಾಗೆ exponential form of complex number, if theta is any modulus of the complex number, e to the power I theta, which is same as your cos theta plus I sin theta, this is called as exponential form of the complex number. So z is equal to x plus iy ಬರೆದಾಗ r into cos theta plus I sin theta, r into e to the power I theta ಅಂತ ಬರಿತೀವಿ. So this r into e to the power I theta, this is called as exponential form, right? So this is exponential form of complex number z. Now suppose if z is x plus iy, z is x plus iy, then z bar, if you write, it is called as the conjugate of the complex number z. Z bar is equal to x minus iy. I sign ಅನ್ನ change ಮಾಡಿ ಬರ್ಕೊಳ್ಬೇಕು. And also if z itself is x minus iy, which shows that z bar is x plus iy ಅಂತ ಬರೀಬಹುದು ಹೀಗೆ, right? So now these things, basic things you need to remember. Now we'll go to the next result. Modulus of z bar is exactly same as mod z. Modulus of complex number z bar. So modulus of conjugate of the complex number is same as modulus of complex number. And amplitude of the conjugate is same as negative of amplitude of z. Mod z1 plus or minus z2 is equal to mod z1 plus or minus mod z2, you can write. So this property I am going to use modulus of z1 bar as conjugate of z1 into z2. So it is conjugate of z1 into conjugate of z2. Again, you can write z1 divided by z2 is exactly same as z1 bar divided by z2 bar. This is very useful one. If you take the product of a complex number z by its conjugate, so it is going to be modulus of z square. It is always right. Then this 12th property is very useful one. Modulus of z1 into z2. Mod z1 into mod z2. Again, modulus of z1 divided by z2 is mod z1 divided by mod z2. And mod z1 plus z2 is less than or equal to mod z1 plus mod z2. Mod z1 minus z2 is greater than or equal to mod z1 minus mod z2. Now we'll go to the next result. Cis theta 1 into cis theta 2, right? So cos theta 1 plus I sin theta 1 into cos theta 2 plus I sin theta 2 multiply ಮಾಡಿದಾಗ it is cos of theta 1 plus theta 2 plus I sin theta 1 plus theta 2, which you can write in the brief form cis of theta 1 plus theta 2 ಅಂತ ಬರೀಬಹುದು. ಹಾಗೆ cis theta 1 by cis theta 2 you can write as cis of theta 1 minus theta 2. Amplitude of z1 into z2 is amplitude of z1 plus amplitude of z2. It is very much similar to usage of your logarithm formulas. ಆ ತರ ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಬೇಕು. ಲಾಗ್ ಆಫ್ ಎಮ್ ಎನ್ ಇದ್ದಾಗ log m plus log n ಬರಿತಾ ಇದ್ರು. ಹಾಗೆ amplitude of z1 into z2 it is amplitude of z1 plus amplitude of z2. In the same way, amplitude of z1 minus z2 it is amplitude of z1 minus amplitude of z2. The amplitude is also called as the argument, right? The value of theta such that, which is between minus pi and plus pi, that is always called as the principal amplitude. So the argument of a complex number is 0, which is not defined. So again, so the argument of positive real number so is always 0. All those things you can look into the problems. I will straight away go to how to identify the amplitude, right? So of complex number. ನೋಡಿ ಈಗ suppose this z is equal to x plus iy ಇರುತ್ತೆ. So and that I can write in the ordered pair form x comma y. ನೋಡಿ ಇಲ್ಲಿ suppose if it lies in first quadrant. So if the z lies in first quadrant, both cos theta and sin theta are going to be positive, and the amplitude, which is nothing but theta, amplitude of complex number theta or z, it is given by theta. It is given by the formula tan inverse of mod y by x. So you can retain that mod as it is. Now suppose if it lies in second quadrant. So in the second quadrant you can observe cos is negative and sin is positive. So in this case, you can write the amplitude theta by using the formula pi minus alpha. It is pi minus tan inverse of modulus of y by x ಅಂತ ಬರ್ಕೊಳ್ಬೇಕು. ಇದೆಲ್ಲ ಶಾರ್ಟ್ಕಟ್ ಫಾರ್ಮುಲಾಸ್ ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಬೇಕು. Then if it lies in third quadrant, both cos and sin are going to be positive or negative. So in this case, your amplitude theta, I can write this as minus pi plus tan inverse of modulus of y by x, you are supposed to write. Then, if it goes to the fourth quadrant, so in the fourth quadrant, all your sin is positive, cos is positive, sin is going to be negative. In that case, the amplitude theta, you can write it as minus tan inverse of modulus of y by x. Very good. So this is how you can choose the amplitude of the complex number based on the position of complex numbers in different quadrants. Now we'll go to the next one. So these results you can all use this Euler's formulas in your regular problem. Sin x expansion and e power x expansion, cos x expansion. So here modulus of z1 plus z2 square plus modulus of z1 minus z2 square is 2 times mod z1 square plus mod z2 square. I'm going to use this last result. Suppose if you take the summation of any four consecutive powers of I, that is always 0. So I have written one of the example. So 1 plus I square plus I cube. So without working that, you can straight away write it as 0. So these are the few things what you need to remember for complex numbers. So now with this, we'll straight away go to problems on these complex numbers. Today, so the weightage of this chapter for your upcoming examination, each year, so every year they are going to give you one problem into this complex numbers. So careful ಆಗಿ ನೋಡ್ಕೊಳ್ಬೇಕು one question ನಿಮಗೆ ಕಂಪಲ್ಸರಿ ಬರುತ್ತೆ ಇದರಿಂದ. Understood? Now, so with this we'll go to question number 1. ಪ್ರಶ್ನೆ 1 ಏನಿದೆ ನೋಡಿ ಇಲ್ಲಿ. Sin x plus I cos 2x and cos x minus I sin 2x are conjugate of each other ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. Then what should be the possible value of x? So these are conjugate of each other. So ಎರಡು conjugate. So one is the conjugate of another one. ನೋಡಿ ಇಲ್ಲಿ ಬರೀತೀನಿ. So sin x plus I cos 2x is equal to, it is conjugate of, this is conjugate of the complex number cos x minus I sin 2x you have. Now, so you know what is the conjugate of this cos x minus I sin 2x. So now I can rewrite this as sin x plus I cos 2x is equal to conjugate of cos x minus I sin 2x. I can write this as cos x plus I sin 2x. Now you are getting two complex numbers as equal. Two complex numbers becomes equal provided the real part and imaginary parts are equal. So equating the real part, sin x is equal to cos x. From this, tan x is equal to 1 ಬರ್ತಾ ಇದೆ, ಕರೆಕ್ಟಾ? So again cos 2x is equal to sin 2x ಬರುತ್ತೆ. So this gives you tan 2x is equal to 1 if you take cos 2x to the other side. Now what I do, tan 2x I am going to write in the tan x form. ಇದಕ್ಕೆ ಫಾರ್ಮುಲಾ ಹಾಕೊಳ್ಳಿ. It is nothing but 2 tan x divided by 1 minus tan squared x ಇದೆ. It is equal to 1. So ಇಲ್ಲಿ tan x ಗೆ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದಾರೆ ನಿಮಗೆ. tan x ಗೆ ವ್ಯಾಲ್ಯೂ ಬರ್ತಾ ಇದೆ. So what is the value of tan x you are getting? So tan x is nothing but 1. So if you make use of tan x as 1 in this, ಏನ್ ಬರುತ್ತೆ ನೋಡಿ. So it is going to be 2 into 1 divided by 1 minus 1 is equal to 1 ಬರ್ತಾ ಇದೆ. So 2 divided by 0 infinity ಬಂತು. So which is not possible, right? So this is not possible. So you cannot have this kind of expression. So therefore it says that the possible value for x does not exist. No value for x ಅಂತ ಹೇಳ್ಬೋದು. This is the usual method of solving the problem. ನೋಡಿ ಇಲ್ಲಿ ಇಷ್ಟೆಲ್ಲ ನಿಮಗೆ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಐಡಿಯಾ ಇಲ್ಲ ಅಂದ್ರೆ ನಿಮ್ಗೆ ಒಂದು ಶಾರ್ಟ್ ಕಟ್ ಮೆಥಡ್ ಹೇಳ್ಕೊಡ್ತೀನಿ. ನಾವೇನ್ ಮಾಡ್ಕೊಳ್ಳೋಣ, we'll straight away put x is equal to 0 in the given question. If you put x is equal to 0, what happens to this? ನೋಡಿ ಇಲ್ಲಿ ಇದರಲ್ಲಿ ಹಾಕೊಳ್ಳಿ, ಕಾಂಜುಗೇಟ್ ಬರೆದಿದ್ದೀನಲ್ಲ ಇಲ್ಲಿ. So sin 2x plus I cos 2x is equal to cos x plus I sin 2x. If you put x is equal to 0 in this one, I am going to verify option C. Sin x sin 0 0 ಆಯ್ತು, plus I into cos 0 it is 1, I ಆಗುತ್ತೆ. Cos 0 is 1, I sin 2x it is 1. I is equal to 1 ಬರ್ತಾ ಇದೆ. That is not correct. Therefore option C is not a choice for you. Again ನೋಡಿ ಇಲ್ಲಿ n is equal to 0 ಮಾಡಿಬಿಟ್ರೆ, n is any integer, I will make it as 0. So you are getting it as x is equal to 0, which is exactly same as your option C. So that I can immediately discard option A is not a choice. Now ಇಲ್ಲಿ n ಗೆ 0 ಮಾಡ್ಕೊಂಡಾಗ you are getting x is equal to pi by 4 ಅಂತ ಬರ್ತಾ ಇದೆ. x equal to pi by 4 ತಗೊಂಡೋಗಿ ಇದರಲ್ಲಿ ಹಾಕೋಣ. So if you substitute x is equal to pi by 4 in the conjugate equation whatever I have written, sin pi by 4 it is going to be 1 by root 2 plus I into cos pi by 2 it is 0. Cos pi by 4 is going to be 1 by root 2 plus I into sin pi by 2 is nothing but 1 I ಆಗ್ತದೆ. 1 by root 2 is equal to 1 by root 2 plus I, which is not possible. So option B is also not a choice. Hence the only left out choice is going to be option D, which is the correct choice for this question. Now we will go to question number 2. ಎರಡನೇ ಪ್ರಶ್ನೆ ಏನಿದೆ? It is the real value of alpha for which the expression is purely, what is that? Real anta ide. So now complex number z, it is given by z equal to, I can write this is z is equal to 1 minus I sin alpha divided by 1 plus 2I sin alpha. So I will bring it to the standard form. Let us rationalize this. So by using the conjugate 1 minus 2, so it is 2I sin alpha. I am going to multiply and divide by the conjugate of that. 1 minus 2I sin alpha in the multiply divide ಮಾಡ್ಕೋಣ. 1 minus 2I sin alpha divided by 1 minus 2I sin alpha. So this on simplification, numerator ನೋಡಿ 1 minus 2I sin alpha whole square ಆಯ್ತು. 1 square 1 plus it is let me take it as minus 2I sin alpha, again minus 2I sin alpha, then it is minus sin alpha, it is not 2I sin alpha, minus into minus plus, so again 2I squared sin squared alpha you get divided by 1 minus 2I sin alpha the whole square. So now I square is minus 1. So this I squared value is minus 1. So that it becomes 1 minus 2 sin squared alpha. It's the real part. We can take it together. So ಇಲ್ಲಿ 2I sin alpha minus I sin alpha minus 3I sin alpha ಬರ್ತಾ ಇದೆ divided by denominator ಏನಾಗುತ್ತೆ 2 square is 4, I square is minus 1. So it becomes 1 plus 4 sin squared alpha. Now I am going to write this in the standard form. 1 minus 2 sin squared alpha divided by 1 plus 4 sin squared alpha ಬರ್ತಾ ಇದೆ. So plus I into it is minus 3 sin alpha divided by 1 plus 4 sin squared alpha. This is the usual method I am solving, but ಅದನ್ನ ಸ್ವಲ್ಪ shortcut method ಮಾಡೋದು ಹೇಗೆ ಅಂತ ಹೇಳ್ತೀನಿ ನಿಮಗೆ ಆಮೇಲೆ. So now it's given that complex number is purely real. That is a hint. Z is purely real. Z is purely real. Since the Z is purely real, imaginary part of Z is equal to 0 height. So imaginary part ಯಾವ್ದಿದೆ? This is nothing but minus 3 sin alpha divided by 1 plus 4 sin squared alpha. It is minus 3 sin alpha divided by 1 plus 4 sin squared alpha is equal to 0. So this on simplification minus 3 sin alpha is equal to 0 height. From this you get sin alpha is equal to 0. But general solution ಬರ್ಕೊಳ್ಬೇಕು. So ಇಲ್ಲಿ alpha is equal to 0 ಆಗ್ತಾ ಇದೆ. Correct? So therefore the general solution for this is it is a sine equation. It is n pi plus minus 1 to the power n into alpha. This is the formula. Alpha ಗೆ 0 ಹಾಕೊಂಡಾಗ n pi ಬರುತ್ತೆ. ನಿಮಗೆ ಆನ್ಸರ್ n pi is going to be the right choice. Option C correct choice ಇದೆ. Suppose ನೋಡಿ ಇದೆಲ್ಲ ಯೂಶುವಲ್ ಮೆಥಡ್ ಮಾಡಿದ್ರೆ ಇಷ್ಟು ನೀವು ಮಾಡ್ಕೊಳ್ಬೇಕಾಗುತ್ತೆ. ಶಾರ್ಟ್ಕಟ್ ಫಾರ್ಮುಲಾ ಏನಪ್ಪಾ ಇದಕ್ಕೆ? What I do, I am going to straight away put alpha is equal to 0 ಹಾಕ್ಬಿಡ್ತೀನಿ question ಅಲ್ಲಿ. If you put alpha as 0, z ಏನಾಗ್ಬಿಡುತ್ತೆ ನೋಡಿ. Numerator it is 1 minus sin 0 is 0, it becomes 0 divided by 1 plus 0 ಇದು 1 ಆಯ್ತು. So obviously it is purely real ಆಗಿದೆ. Correct? So if it is purely real, I am going to take alpha as 0. Sin function ನೋಡಿ, obviously sin alpha is equal to 0 ಆಗುತ್ತೆ. So sin alpha 0, we are straight away getting into the last step. So alpha is nothing but, so our x is nothing but, x is, our x is nothing but n pi plus minus 1 to the power n into alpha, x pi plus minus 1 to the power n into alpha. So it is alpha is 0 from this. You can straight away write x is equal to n pi ಅಂತ ಬರೀಬಹುದು. ಆಪ್ಷನ್ ಸಿ ಇದಕ್ಕೆ ಸರಿ ಉತ್ತರ ಇರುತ್ತೆ. ಆ ತರ ಶಾರ್ಟ್ ಕಟ್ಸ್ ಅನ್ನ ಕ್ರಿಯೇಟ್ ಮಾಡಬಹುದು. ಈ ತರ ಲೆಂತಿ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇದ್ದಾಗಲೂ ನೀವು ಶಾರ್ಟ್ ಕಟ್ಸ್ ನ ಮಾಡ್ಕೊಳ್ಬಹುದು. ನೋಡಿ ಕ್ವೆಶ್ಚನ್ ನಂಬರ್ 3 ಏನಿದೆ ನೋಡೋಣ. z is equal to x plus iy is any complex number. So z is equal to x plus iy lies in the third quadrant, and z bar by z also lies in the third quadrant ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಲ್ವಾ. So then what should be the possible values of x and y? ಇಲ್ಲಿ z lies in third quadrant. Z is equal to x plus iy lies in third quadrant. This is the question. So if it lies in third quadrant, x should be negative and y is also negative. X less than 0 ಇದೆ, y less than 0 ಇದೆ. ಹಾಗೆ z bar divided by z ನೋಡ್ಕೊಳ್ಳಿ. It is nothing but x minus iy divided by x plus iy. ಇದನ್ನ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಫಾರ್ಮ್ ತಗೊಂಬರೋಣ. To bring it to the standard form, I am going to rationalize this by using the conjugate of the denominator complex number x minus iy divided by x minus iy ಇಂದ ಮಾಡ್ಕೊಳ್ಳೋಣ. Numerator x minus iy, so into x minus iy, it becomes x square minus x into iy minus x into iy minus 2i into xy, you get minus minus plus, right, I squared into y squared divided by, you got x square plus y square. ನೋಡಿ ಇಲ್ಲೊಂದು ಫಾರ್ಮುಲಾ ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ. If you want to multiply a plus ib into, right, so a plus ib into a minus ib, a plus ib, if you want to multiply with a minus ib, complex number multiplied by its conjugate. ನೀವೆಲ್ಲ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತಾ ಕೂತ್ಕೊಳ್ಬಾರ್ದು. ರಿಯಲ್ ಪಾರ್ಟ್ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಇಮ್ಯಾಜಿನರಿ ಪಾರ್ಟ್ ಸ್ಕ್ವೇರ್ ಬರ್ಕೊಳ್ಬೇಕು. ಸೊ ದೋಸ್ ಥಿಂಗ್ಸ್ ಯು ನೀಡ್ ಟು ರಿಮೆಂಬರ್. ಈಗ ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ x ಸ್ಕ್ವೇರ್, ದಿಸ್ i ಸ್ಕ್ವೇರ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ minus 1 minus y square. So divided by the denominator, I am going to write x square plus I square plus I into, we can have minus 2xy divided by x square plus y square. Correct? So this is z bar divided by z. So they are given that this also lies in third quadrant ಅಂತ ಕೊಟ್ಬಿಟ್ಟಿದ್ದಾನೆ. So it lies in, this lies in third quadrant. This is the question they are given. Understood? So ಈಗ ನೀವೇನ್ ಮಾಡ್ಕೊಳ್ಬೇಕು, when does this lies in third quadrant? So real part also negative, imaginary part also negative ಇರಬೇಕು. Therefore I can straight away write from this x square minus y square divided by x square plus y square should be less than 0. So from this x square minus y square is less than 0, it gives you x square is less than y square. ನೋಡಿ ಇಲ್ಲಿ x square less than y square ಬರ್ತಾ ಇದೆ, ಇಲ್ಲಿ x is less than 0, y is less than 0 ಅಂತ ಇದೆ. ಅಂದ್ರೆ so ಇಲ್ಲಿ you are having two values of x which are so negative. So since x square less than y square ಅಂತಂದ್ರೆ y square should be negatively more than x square, right? y ಇಲ್ಲಿರಬೇಕು and x should be like this. So therefore y is greater than x ಇರಬೇಕು ನಿಮಗೆ ಆನ್ಸರ್, right? So sorry, y is less than x because negative number line ಅಲ್ಲಿ ಇದೀವಿ ನಾವೀಗ. So value of y is negatively more, that means y is going to be less than x. So answer for this y is going to be less than x, and here they are both are less than 0, so it is going to be lesser than 0. Y less than x less than 0. Option C is going to be the correct answer for this question. Now we'll move to question number 4. And here the value of complex number z plus 3 into z bar plus 3 is equivalent to ಅಂತ ಇದೆ. ನೋಡಿ ಇದು ರೆಗ್ಯುಲರ್ ಆಗಿ ಸಾಲ್ವ್ ಮಾಡಿದಾಗ ಲೆಟ್ ಅಸ್ ಟೇಕ್ z is equal to x plus iy ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. ಸೊ z plus 3 into z bar plus 3 ನೀವು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ x plus iy plus 3 ಇರುತ್ತೆ into x minus iy plus 3 ಬರುತ್ತೆ. So now I can write it as x plus 3 plus iy multiplied by, you can have x plus 3 minus iy. This is how you can combine these two. Now it is very much same as combining a complex number with its conjugate. So now you can write the product of this. Its real part square, x plus 3 the whole square plus imaginary part y square. ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿಕೊಂಡ್ರೆ x square plus 9 plus 6x plus y square ಬರ್ತಾ ಇದೆ. Now we will go to the option. Okay, first option check ಮಾಡ್ಕೊಳ್ಳೋಣ. Modulus of z plus 3 the whole square. Option A ನೋಡೋಣ ಏನ್ ಬರ್ತಾ ಇದೆ ಅಂತ. So it is nothing but modulus of x plus iy plus 3 square. Modulus of this is square root of, this is x plus 3 square plus y square. ಇದಕ್ಕೆ square ಹಾಕೊಳ್ಬೇಕು, right? So now the root goes with the square. The option you left with, it is nothing but x plus 3 the whole square plus y square ವಾಪಸ್ ಬರ್ತಾ ಇದೆ. Now you can look at this. So the modular, the product what you got here, it is exactly same as the product what you are getting. So therefore, option for this question, it is going to be option A. This is the usual method of solving this. ನಿಮಗೆ ಇನ್ನೊಂದು ಸಿಂಪಲ್ ಶಾರ್ಟ್ ಕಟ್ ಹೇಳ್ತೀನಿ ನೋಡಿ ಈಗ. Since there is no restrictions on z, what you can do, I will make z as 0. Complex number z na 0 ಮಾಡ್ಬಿಡೋಣ. So if you make z as 0, conjugate ಏನ್ ಮಾಡುತ್ತೆ, conjugate to 0 ಆಗಿಬಿಡುತ್ತೆ, right? So this is the shortcut method for this particular problem. So now conjugate of any real number is always itself, that you need to remember. So now with this, if you go to z plus 3 into z bar plus 3, ಇದರಲ್ಲಿ ಹೋದಾಗ it is 3 into 3 which straight away gives you 9. Option A ನೋಡಿ ಏನ್ ಬರ್ತಾ ಇದೆ, mod z plus 3 square. So it is 3 square you get, which gives you 9. Straight away you get the option within one step. None of the other options will coincide. Option B ಏನಾಗುತ್ತೆ, z ಗೆ 0 ಹಾಕಿದ್ರೆ mod minus 3 3. This is again 3, so this is not a choice. Option A is going to be the correct answer for this question. Now we'll move on to question number 5. Question number 5 ನೋಡಿ ಹೇಗಿದೆ, if 1 plus I whole to by 1 minus I whole to the power x equal to 1, then what should be the possible value of x ಅಂತ ಕೇಳಿದ್ದಾರೆ. So what I can do here, 1 plus I divided by 1 minus I whole to the power x. ಇವೆಲ್ಲೂ shortcut methods ನ ಮಾಡಬಹುದು, but so if you make use of shortcut methods you need to work out little bit more. So ಅದಕ್ಕೆ ನಾವೇನ್ ಮಾಡೋಣ, ಸೊ ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಕೊಳ್ಳೋಣ. 1 plus I divided by 1 minus I, ಈ ಪವರ್ ಒಳಗಡೆನೆ ರಾಷನಲೈಸ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಮಲ್ಟಿಪ್ಲೈ ಅಂಡ್ ಡಿವೈಡ್ ಬೈ 1 plus I whole to the power x is equal to 1 ಮಾಡಿ. So numerator 1 plus I the whole square is 1 square plus I square plus 2I ಆಯಿತು. Denominator complex number multiplied by its conjugate, 1 square plus 1 square whole to the power x is equal to 1. Now it gives you 1 minus I plus 1 minus 1 plus 2I you have, divided by 2 you get, the whole to the power x is equal to 1. Clear? So minus 1 plus 1 gets cancelled, these two gets cancels. The simplified expression whatever you are getting, it is nothing but I in the left hand side to the power x is equal to 1 ಬರ್ತಾ ಇದೆ. ಈಗ what I do, x ಗೆ 1 ಹಾಕೋಣ ನಾವು. So if you make x as 1, so you are going to get I which is not equal to 1. So if you make x as 2, you get the left hand side I square, so it is equal to minus 1, its value is not equal to 1. Suppose if you make x as 3, so the left hand side becomes I cube, which you can write as I into I square which becomes minus I, it is not equal to 1. ಹಾಗೆ x is equal to 4 ಮಾಡ್ಕೊಂಡಾಗ suppose if you put x as 4, so it becomes I to the power 4, which you can write as I square whole square. So it is minus 1 squared. So minus 1 squared is nothing but plus 1. That is possible. So therefore, so in general, the possible value of x, it should be multiple of 4. So x should be multiple of 4 ಇರಬೇಕು. Answer for this is going to be x is equal to 4n. Option B is going to be the right choice for this question. We'll move on to question number 6. The sixth question ನೋಡಿ ಏನಿದೆ, again a very interesting question for you. The real value of alpha, real value of x satisfied the equation 3 minus 4ix divided by 3 plus 4ix is equal to alpha minus I beta. If real value of x satisfied by the equation, so question higirbeku, satisfied by the equation, it is equal to 3 minus 4ix divided by 3 plus 4ix is equal to alpha minus I beta. If what should be the possible value of alpha square plus beta square? ನನಗೆ ಕ್ವಶನ್ ಏನಿದೆ, ಆಲ್ಫಾ ಮೈನಸ್ ಐ ಬೀಟಾ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇಟ್ ಈಸ್ 3 ಮೈನಸ್ ಐ ಇಂಟು 4x ಡಿವೈಡೆಡ್ ಬೈ 3 ಪ್ಲಸ್ ಐ ಇಂಟು 4x. ಈಗ ಈ ತರ ಬರ್ಕೊಳ್ತಾ ಇದ್ದೀನಿ. ವಾಟ್ ಐ ಡೂ, ಇಲ್ಲಿ ಸಿಂಪ್ಲಿ ಯು ರಿಪ್ಲೇಸ್ ಐ ಬೈ ಮೈನಸ್ ಐ. ಅದರ್ವೈಸ್ ಮಾಡ್ ತಗೊಂಡು ಮಾಡಬಹುದು ನೀವು. ಅದರ್ವೈಸ್ ವಾಟ್ ಐ ಡೂ, ಐ ವಿಲ್ ಸಿಂಪ್ಲಿ ಅಪ್ಲೈ ಮಾಡ್ಯುಲಸ್ ಫಾರ್ ದಿಸ್. ಮಾಡ್ಯುಲಸ್ ಅಪ್ಲೈ ಮಾಡಿಬಿಟ್ಟಾಗ ಇದು mod ಆಫ್ ದಿಸ್ ಹೀಗೆ ಬರುತ್ತೆ. ಮಾಡ್ಯುಲಸ್ ಆಫ್ ದ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಇಟ್ ಇಸ್ ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆಫ್ ಆಲ್ಫಾ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಬೀಟಾ ಸ್ಕ್ವೇರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು, ಇಲ್ಲಿ mod ನ್ಯೂಮರೇಟರ್ ದಿಸ್ ಐ ಕ್ಯಾನ್ ರೈಟ್ as ಮಾಡ್ಯುಲಸ್ ಆಫ್ 3 minus I into 4x divided by ಮಾಡ್ಯುಲಸ್ ಆಫ್ 3 plus I into 4x using property of modulus. ನೋಡಿ, ನ್ಯೂಮರೇಟರ್ ಮಾಡ್ಯುಲಸ್ ತಗೊಂಡಾಗ ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆಫ್ 9 ಪ್ಲಸ್ 16x ಸ್ಕ್ವೇರ್ ಆಯ್ತು, ಡಿವೈಡೆಡ್ ಬೈ ಡಿನಾಮಿನೇಟರ್ ಇಸ್ ಆಲ್ಸೋ ರೂಟ್ ಆಫ್ 9 ಪ್ಲಸ್ 16x ಸ್ಕ್ವೇರ್ ಬರ್ತಾ ಇದೆ. ಬೋತ್ ಗೆಟ್ಸ್ ಕ್ಯಾನ್ಸಲ್ಸ್, ಯು ಗೆಟ್ 1. ಸೊ ನೌ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಕ್ವೇರ್ ಆನ್ ಬೋತ್ ಸೈಡ್ಸ್ ಆಫ್ ದಿಸ್. ಯು ಲೆಫ್ಟ್ ವಿತ್ ಆಲ್ಫಾ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಬೀಟಾ ಸ್ಕ್ವೇರ್ ವಿಚ್ ಗಿವ್ಸ್ ಯು 1. ಸೊ ಈಗ ನೋಡಿ, ಆಲ್ಫಾ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಬೀಟಾ ಸ್ಕ್ವೇರ್, ಆನ್ಸರ್ ಫಾರ್ ದಿಸ್ ಕ್ವೆಶ್ಚನ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಆಪ್ಷನ್ ಎ ಬರ್ತಾ ಇದೆ. ಸೊ ಅದನ್ನ ಸರಿ ಉತ್ತರ ಅಂತ ನೀವು ಇಟ್ಕೊಳ್ಬಹುದು. ನಾವು we'll go for 7th question. ನೋಡಿ ಏನಿದೆ, 7ನೇ ಪ್ರಶ್ನೆ. Which of the following is correct for any two complex numbers z1 and z2? Which of the following are correct for any two complex numbers ಅಂತ ಕೇಳಿದ್ದಾರೆ. Modulus of z1 into z2 is equal to mod z1 into mod z2. So this is nothing but modulus of z1 into mod z2. It is mod z1 mod z2. This is correct. Argument of z1 into z2, argument of z1 into argument of z2 ಬರುತ್ತೆ. No, it should be plus ಇರಬೇಕಿಲ್ಲಿ. So this is not a correct choice. And mod z1 plus mod z2, it is not equal to, it is greater than or equal to ಬರಬೇಕು. So this is not a choice and this is not a choice. The correct answer for this is going to be option A. It is the standard result. Now we'll go for question number 8. 8ನೇ ಪ್ರಶ್ನೆ ಏನಿದೆ ನೋಡ್ಕೊಳ್ಳಿ. The point represented by the complex number, very interesting question. The point represented by the complex number 2 minus I is rotated about origin through an angle of pi by 2 in the clockwise direction ಅಂತ ಇದೆ. ಸೊ ನೋಡಿ, ಹೀಗೆ ಕ್ವಶನ್. So you are having the coordinates, it is x dash and y dash with origin O. Complex number 2 minus I. So if you take z is equal to 2 minus I, it is can be written as 2 comma minus 1. X positive ಇದೆ, y negative ಇದೆ. x2 y minus 1, x2 and y minus 1 means z may somewhere here, it is 2 comma minus 1, right? So this is what you have. Now it is rotated through an angle of pi by 2. So 90 degrees in the origin about origin you are going to rotate. If you rotate, so 90 degrees about the origin, then obviously ನೋಡಿ ಇಲ್ಲಿ new complex number ಇಲ್ಲಿ ಬಂದ್ಬಿಡುತ್ತೆ third quadrant ಬರುತ್ತೆ. So if the complex number comes to the third quadrant, then obviously both so x and y are going to be negative. Real and imaginary part ಎರಡು ನೆಗೆಟಿವ್ ಇರಬೇಕು. ಸೊ ಇಲ್ಲಿ ರಿಯಲ್ ಅಂಡ್ ಇಮ್ಯಾಜಿನರಿ ಪಾರ್ಟ್ ಯಾವ್ದು ಎರಡು ನೆಗೆಟಿವ್ ಇದೆಯಪ್ಪ ನೋಡ್ಕೊಳ್ಬೇಕು. ಸೊ ಯಾವ್ದು ಎರಡು ನೆಗೆಟಿವ್ ಇದೆ ನೋಡ್ಕೊಳ್ಳಿ ಈಗ. ಆಬ್ವಿಯಸ್ಲಿ ಆಪ್ಷನ್ ಬಿ ಮಾತ್ರ ನಿಮಗೆ ನೆಗೆಟಿವ್ ಇದೆ, ಉಳಿದಿದ್ದೆಲ್ಲ ಸೊ ನೋಡಿ ಇದೆಲ್ಲ ಇದು ಆಪ್ಷನ್ ಎ 1+2i ಅಂತಂದ್ರೆ ಸೊ ನಿಮ್ಗೆ ಏನಾಗುತ್ತೆ 1+2i it is going to be the first quadrant, so this is not a choice. 2+i first quadrant ಆಗುತ್ತೆ, that is not a choice. -1+2i it lies in the same quadrant, that is not a choice. So now the correct answer is going to be option B. Diagram use ಮಾಡ್ಕೊಂಡ್ರೆ ನಿಮ್ಗೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಅನಲೈಸ್ ಮಾಡಬಹುದು. ಅದರ್ವೈಸ್ ನೋಡಿ ಈಗ ನೀವು ರೆಗ್ಯುಲರ್ ಆಗಿ ಮಾಡಬೇಕು ಅಂತ ಅಂದಾಗ you are rotating this in the clockwise direction through an angle of 90 degrees. Therefore the angle is going to be -pi/2, negative angle ಬರುತ್ತೆ, -pi/2 ಬರುತ್ತೆ. So here you got z, original z ನಿಮ್ಗೆ ಏನಪ್ಪ ಇದೆ, it is 2 - i ಅಂತ ಇದೆ. Then new position of complex number, this is the usual method of finding it. New position of z, it is given by z into e to the power -i/2 ಅಂತ ಬರೀತೀವಿ. So z already ಇದೆ ನಿಮ್ಮ ಹತ್ರ, it is 2 - i into e to the power -i/2 ಅಂದ್ರೆ it is cos pi/2 minus I sin pi/2 i. So now this on simplification, it is 2 - i multiplied by cos pi/2 is 0 minus i. So this is nothing but 2 - i into -i ಬರುತ್ತೆ. It is -2i plus i square you are getting. I square value ನಿಮಗೆಲ್ಲ ಗೊತ್ತಿದೆ, it is going to be -1, so that it is -1 minus 2i ಬರ್ತಾ ಇದೆ. ನೋಡಿ ಈಗ ನಾವು ಆನ್ಸರ್ ಉತ್ತರ ಬರ್ದಿರೋದು ಸರಿ ಇದೆಯಾ ನೋಡ್ಕೊಳ್ಳಿ. -1 minus 2i is exactly correct. So if you have some basic idea of representation of complex numbers geometrically, you can easily make use of the answers without working the problem. So ಇದಕ್ಕೆ correct ಉತ್ತರ -1 minus 2i. So now we'll go to question number 9. ಒಂಬತ್ತನೇ ಪ್ರಶ್ನೆ ಇದೆ ನೋಡಿ. Let x, y belongs to R. So x, y belongs to R ಅಂದ್ರೆ x and y are real numbers. X plus iy is a non-zero complex number ಅಂತ ಇದೆ. So z is equal to x plus iy it is not non-zero, it is non-real. Understood? Non-real ಅಂತಂದ್ರೆ imaginary ಇರಬೇಕು. So non-real means it is going to be imaginary. Understood? So it may be imaginary ಇರುತ್ತೆ. ಇದು imaginary ಇದ್ದಾಗ imaginary part should be present. So imaginary part should not be equal to 0. Therefore for this you are supposed to have the direct answer. Imaginary part is nothing but, so imaginary part of z, it should not be equal to 0. So imaginary part of z here, it is y, which is not equal to 0. Therefore option D is going to be the correct answer for this question. Okay, we'll go to question number 10 ನೋಡೋಣ ಏನಿದೆ. 10ನೇ ಪ್ರಶ್ನೆ. So here 10th one, if a plus ib is equal to c plus id, then which of the following results holds good? ಎಲ್ಲ ಸ್ಕ್ವೇರ್ಸ್ ಅಲ್ಲಿ ಇದೆ. ರಿಯಲ್ ಪಾರ್ಟ್ ಸ್ಕ್ವೇರ್, ಇಮ್ಯಾಜಿನರಿ ಪಾರ್ಟ್ ಸ್ಕ್ವೇರ್ ಆ ತರ ಇದೆ. ನಿಮ್ಗೆ ಕಾಂಪ್ಲೆಕ್ಸ್ ನಂಬರ್ಸ್ ಅಲ್ಲಿ ರಿಯಲ್ ಪಾರ್ಟ್ ಸ್ಕ್ವೇರ್, ಇಮ್ಯಾಜಿನರಿ ಪಾರ್ಟ್ ಸ್ಕ್ವೇರ್ ಬಂತಪ್ಪ ಅಂದ್ರೆ ಇಟ್ ಡೀಲ್ಸ್ ವಿತ್ ದೇರ್ ಮಾಡ್ಯುಲಸ್. ಅದಕ್ಕೆ ಜ್ಞಾಪಕ ಇಟ್ಕೊಂಡಿರ್ಬೇಕು. Modulus of those two complex numbers it deals with. So therefore a plus ib is equal to c plus id. A plus ib is equal to c plus id ಇದ್ದಾಗ I will apply the mod, right? So mod apply ಮಾಡ್ತೀನಿ ಇದಕ್ಕೆ. It is a plus ib, mod a plus ib is equal to mod c plus id. So now modulus of a plus ib is nothing but root of a square plus b square. is equal to root of c square plus d square. We will square on both sides of this. It is a square plus b square is equal to c square plus d square. And a square plus b square is equal to c square plus d square. Option D is going to be the correct answer for this question. We will go to question number 11. 11ನೇ ಪ್ರಶ್ನೆ ಏನಿದೆ ನೋಡಿ. 11th question. The complex number z which satisfies the condition modulus of I plus z divided by mod I minus z equal to 1 lies on. So, which of the following is correct? Right? So, ನೋಡೋಣ ಏನು ಬರುತ್ತೆ. We will simplify this one. So, let us straight away take z is equal to x plus iy ತಗೊಂಬೋಣ. So now this is, I will split this one, modulus of I plus z divided by modulus of I minus z anta ide, right? So divided by modulus of I minus z, it is equal to 1. I am just using the property of modulus. Now what you can do here, modulus of 1 plus I z is nothing but ix plus iy divided by modulus of, this is ily though. So this is going to be I. So I minus of x plus iy is equal to 1 ಬರ್ತಾ ಇದೆ. ನೋಡಿ ಇಲ್ಲಿ I will straight away apply the modulus x square plus, otherwise if you don't recognize that, let me write another step, ಇನ್ನೊಂದು step ಬರೆಯೋಣ ಇದಕ್ಕೆ. So I will separate this and write. ನೋಡಿ ಈಗ if you write this one, ಇದು ಹೀಗೆ ಬರುತ್ತೆ, modulus of x plus I ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್ ತಕೊಂಡಾಗ 1 plus y ಬರುತ್ತೆ divided by here modulus of minus x, ಇಲ್ಲಿ I ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್ ತಕೊಂಡ್ರೆ plus I into 1 minus y ಬರುತ್ತೆ, right? This is equal to 1. ಈಗ modulus ಬರ್ಕೊಳ್ಬೇಕು ನ್ಯೂಮರೇಟರ್ ಅಲ್ಲಿ. So modulus of that, it is square root of real parts square. It is x square plus 1 plus y the whole square you get, right? Divided by denominator ge modulus tagoli, square root of minus x the whole square is x square plus imaginary part is nothing but 1 minus y square. This is equal to 1. Iga I am going to shift the denominator to the left hand side. I am going to square that so that it becomes x square plus 1 plus y the whole square. So this will be equal to x square plus 1 minus y the whole square ಬರ್ತಾ ಇದೆ ನಿಮಗೆ. So x square cancel ಆಯ್ತು. Now 1 plus y the whole square is equal to 1 minus y the whole square ಬರ್ತಾ ಇದೆ. You can expand this one. It is 1 plus y square plus 2y. It is equal to 1 plus y square minus 2y ಬರ್ತದೆ. 1 plus y square gets cancels with the same. Minus 2y ಈ ಕಡೆ ತಗೊಂಡಾಗ 2y plus 2y, 4y is equal to 0 ಆಯ್ತು. y is equal to 0 ಬರ್ತಾ ಇದೆ. ಸ್ಟೂಡೆಂಟ್ಸ್ ಎಲ್ರಿಗೂ ಗೊತ್ತಿದೆ y is equal to 0 ಬಂತಪ್ಪ ಅಂದ್ರೆ, so y equal to 0 always represent the x-axis. So this is going to represent equation of x-axis. So therefore, so your complex number lies on, ಈಗ ಆನ್ಸರ್ ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ. So it obviously lies on the x-axis. Option B is going to be the correct answer for this question. Now 12ನೇ ಪ್ರಶ್ನೆ ಏನಿದೆ ನೋಡೋಣ. Option B is going to be the correct answer for this question. Now